Okay. Right, Bismillahirrahmanirrahim. Okay folks, welcome back. I'm going to call this one video number 2. Please make sure you watch the first video, which has got the same title, Volume of a Prism. And that one had the introduction, introducing the topic. I'm going to launch myself straight into the questions. I've got 3 questions to do in this particular video. Okay, so if you need any introduction, please refer back to the earlier video. Right, let's get started without any further delay. Right. Okay, now where's my left hand gone? I have to do that other thing. Okay, right. So we have, for example, in this particular question, the diagram shows a cuboid, this one here. So we have a length, okay, we have the thickness, and we have the width. So I'm just going to relabel this 50 over here. And I'm going to label that as thickness. That's my length. That's my width. Okay. The diagram shows the cuboid. Work out the volume. Now, the concept that we used before in the previous video about volume, looking at volume, is the area of the face of the shape times by the thickness. Okay, we also use so the face here is a rectangle. And here's our thickness. Okay. Now, so we say here, the volume is equal to the area of the face times by how thick it is. Now, this particular face here is a rectangular face, so the formula for the area of a rectangle is length times by width. Length times by width. Times by the thickness. The thickness is 30. Okay. Now, the length is 15 and the width is 50. Now, let's work this out. This one is a calculator question. Right, so let's grab our calculator, which was here a second ago. Just going to run it. Okay. Now, we have 15 times by 50 times by 30, and that gives us an answer of 22500. Done. Okay, so the area of the face is this part times by that. Okay, that's enough of that particular question, folks. Let's quickly move on to question number 2 and then 3. So let's get rid of this now and clear the board. Right. Okay. Right, here we go. Here's our next question over here. We have ourselves a triangular prism. I'm going to use the same color coding. This is the face. So when you're working out volume, volume is to do with the area of the shape that we have. We have a triangular shape which has been pushed all the way through, and we call this part our thickness. So the 9 centimeters is equal to our thickness. This is the base of our right angle triangle, and this is our height. Okay. Now at the moment, because we're working at the volume, we won't be using this measurement at the moment. They have given us that measurement, but we won't be using that measurement at all. We need that measurement when we're doing surface area. So let's have a look at this question. What's the general formula? We said the volume is equal to the area of the face times by the thickness. Okay, right. This is the face. What face is it? A triangular face. So what is the formula for the area of a triangle? So it's a triangle base times by height divided by 2. Okay, and then we're going to time that by the thickness. Alright, here we go. So now what we've done, we've looked at the question, we've used that general formula and we made it specific. So volume is about of prism is about the area of the face, like the area of the shape that we have, the shape is made from, multiplied by how thick the shape is. So based on y divided by 2 times by t, let's start putting the values in there and let's finish this question off. Base is 3, height is 4, 3 and 4. 3 times by 4 divided by 2 times that by the thickness, which is 9 centimeters. Okay. So we have 3 times by 4 will give us 12. 12 divided by 2 will give us 6. So 6 times by 9. So the volume is equal to 54 centimeters cubed for this triangular prism. Okay, let's quickly underline that and finish the question. Okay folks, thank you very much for doing this question. Let's quickly go to the last question of this particular video, looking at cylinders. Alright, here we go. Alright, let's quickly put the board down. Alright. Okay, right, let's get back to our basic formula again. Now looking at the volume of a cylinder, this could be the context, for example, of a swimming pool. For example, let's just change this, adjust it a bit. Okay, get rid of the C. So for example, let's say this is a swimming pool, it has a radius of 3.8 meters. It has a thickness, well they would probably use the word height, I'm still going to use thickness. Thickness of 2.5 meters, how much volume is contained in the swimming pool. So that could be the context of this type of question in examination. So we've been asked to work to 3 significant figures in this particular question, and we're going to use pi as 3.142. Right, so let's have a look, how do we work out the volume of this? So let's get, okay, so we're going to write down here, we're looking for the right space. Right, let's change colour. So we start with the basic formula. So volume is equal to, okay, is equal to the area of the face. Okay, times it by the thickness, or T for short. Okay, and as the previous theme, the area of the face. Where's our face in this particular shape? Here's our face. This is the face. The face is what? It's a circle. So the face that we have here is a circle. So the face of the shape. Now, what is the formula for the area of a face? Area of a circle is pi times by the radius squared. So this shape, volume, is made up of a circle that's been pushed to a thickness of 2.5 meters. Right, let's get cracking with this particular question. That's our general formula. Now we made it specific for this particular question. Now we need to just throw in the numbers. Now, so we're going to say a volume is equal to pi, which the asked us to use 3.142. And we times that by the radius squared, which is 3.8 meters. 3.8 squared. Okay, and then we're going to multiply that by the thickness. And the thickness here is in the height, in context of the question, 2.5 meters. Okay, some students have a habit of putting in the units into the calculation here. That's something that can confuse the matters. Please leave the units out in this stage of the calculation, put it in only at the end. So let's have a look at that. We need to put this part into the calculator. Okay, right, so we got here 3.14 times by 3.8 squared times by 2.5, and that gives 113.354. Now, the question says here, give the answer to 3 significant figures. That's my first significant figure, my first non-zero digit, second one, and third one. So what that's requiring us to do that's requiring us to do is look at first, second, third, and look at this value over here. If this one is 5 or more, we add 1. If it's less than 5, we leave it alone. So this part of the question remains. So 113.354, if we round that off to 3 significant figures, will give us a volume of 113 meters cubed only. Okay, the reason why, because we're already at the decimal point here, that's what the third significant figure is. You don't fill in any more zeros, you have to truncate the number, cut that part of the number off. That's the decimal version of it. If the number 3 was slightly further down this side, then you'd have to fill up zeros to the gap to the decimal point. So the answer for this particular question, in context of a swimming pool, 3.8 meter radius, 2.5 meters depth, that would have a volume of 113 meters cubed. Okay folks, I hope this style of question and style of thinking about the question has helped you with your understanding of volume questions for examinations. Please come and join us again in some more videos. Thank you very much for joining us.